So I'm going to go over the Unit 8 test review, and this test is over exponentials and logarithms. So number 1 says a real estate agent estimates that the value of a house could increase 4% each year. It said write an equation that models the growth in value for a house that is initially valued at $122,000. So when we're talking about this one, our equation is A to the T is equal to A times 1 plus the rate of interest to the power of the time. Okay, so A is our initial amount of money. Okay, so when we're writing our equation, it's going to be A of T is equal to our 122,000, and then it's going to be 1 plus our interest rate. It says here's 4%. Remember, we're going to move this decimal 2 places to the left, so it's going to end up being 0.04. And then our time for this one is just T, because we don't have a time yet. But when we come down here, that's going to end up being equal to 10. Okay, so when we talk about how much is the house worth in 10 years, then we're going to apply that 10 to that. So when we do this, again, remember, it's going to be 122,000. And this will be 1.04 when we add those two together, and we're going to take that to the 10th power. Okay, so when we do this, we're going to get $180,589.80. Okay. Now, this part C says, what will the value of the house be in the year 2050? So the first thing we have to do, it says use the year 2021 as year 0. So we're going to subtract 2021 from this, and that's going to give us 29 years. And then we're going to work that problem. So we're going to do the same thing we did before, 122,000. And we're going to do the 1.04, but this time we're going to take it to the 29th power. And when we do that, we're going to get 380,475.4. And in the calculator, it's 0.4771. So that third 7 is going to round up the 7 to an 8. So this is going to be $380,475.48. All right, so on this one, says a computer valued at $6,500 depreciates at the rate of 14.3% per year. Write a function that models the value of the computer. So here again, our A of T. Now the difference with this one is it's depreciation. Okay, so that means that we're going to subtract. So we're going to do our 6,500, and we're going to do 1 minus, and again, remember, we're moving this 2 places. It's going to be 0.143. And then by whatever the time is. And notice here it says 3 years, so we're going to end up putting 3 up there. So when we do that, our equation is going to be 6,500, 1 minus 0.143, and so here again, this is going to be $4,091. And when I put this one in the calculator, it gave me 248. So that's going to round up to be 25 cents. So for this next equation, we have A equals P times 1 plus R over N to the N times T power. So we want to talk about our final amount is going to be our A. Our P is going to be what we start with. So that's what this is going to be. That's going to be P. And then our rate of interest is this. And then it says daily, so there's 365 days in a year, so that's going to be our N. And then this 3 right here is going to be equal to our T. Okay, so when we write our formula, we're going to do 7,300, and then we're going to do 1 plus our rate of interest. Remember, again, we got to move this 2 places to the left, so that's going to be 0.07, and we're going to put that over. That's going to be 0.07, and that's going to be over our 365 because there are 365 days in a year. And then we're going to do the 365 times the 3 up here. So when we do this, what we get for our answer is going to be 9,005. And again, when I put it in the calculator, I get 0.668, so that second 6 is going to round up to be a 7. All right, so on this one, again, same thing. We've got P here. This is our rate of interest, compounded monthly this time, so n is going to be equal to 12, and then this is going to be our t. So our formula is going to be 55,000 times 1 plus 0.16, again remember, moving it 2 places to the left, over 12, and then we're going to do that 12 times 5. So when we do that, we get, for our answer, 121,759. And again, this was 0.386, so it's going to be 0.378. So it's 0.378, so that 7 is going to round up to be an 8. Okay. So here we go again. This one is the same. So we got our P here, P there, rate of interest there. Weekly means there's 52 weeks in a year, so that's going to be n is equal to 52, and then this is going to be t is equal to 2. Okay, so we've got 28,600 times 1 plus 0.079. Again, remember, we're moving this way, right? So, sorry, I did that wrong. So we're going to move it 2 places. So you're going to end up with 0.079 like that, divided by 52, and then we're going to do that 52 times our 2 up here. Okay? So when I do that, I get 33,491. And again, I got 0.3374, so it's going to be 0.34 because the 7 is going to round that 3 up to a 4. Okay? So now this is rewrite each equation in exponential form. So if you recall, we're going to take our base, and it's going to be our base. We're going to take what's on the other side of the equal sign. It's going to become our exponent. And then we're going to take what we're taking the base of, and it goes to the other side of the equal sign. So here again, 289 to the 1/2 power equals 17. 14 to the negative 2 is equal to 1 over 196. And 3 to the 4th is equal to 81. The next one, we're going to, so I'm going to put this in the calculator, but first I see that this is 1/5, and so if that is less than, if it's between 0 and 1, then we know that this is going to be a decay function. Remember, our asymptote has to do with that value right there. So our asymptote is going to be, well, I'm sorry, our intercept has to do with that right there. So that's going to be 0, 5. So that means we're going to intercept right there. Our asymptote for these, remember, is going to be y equals 0 always, because that's what it's always going to be for decay and growth. So again, if we look at this on the graph, it's going to look something like this. I had 1, 1 here when I looked at it. So it comes down like that, and then it curves. Remember, it's going to get really close to that x-axis, but it's never actually going to touch it. So now when we look at this graph, when we move to the right here on the graph, it's going to approach what? Infinity. It's going to approach there. Now on y'all's work, on you guys' notes, make sure you're looking at this because these are flipped. And then as it goes to negative infinity, where's it going up here, guys? So as it goes to the left, remember negative infinity is over here. Where's the graph going? It's going to positive infinity. And our domain, obviously, are there any restrictions on the x values? No. So that's going to be all real numbers. But the range, all of our y values are going to be greater than 0. And that's, again, because this whole graph is above the x-axis. Okay, so now when we talk about finding the inverse of these problems, so we're going to put x where y was and y where x was first. So that's x equals 2 log base 7 of y minus 5. So I'm going to go ahead and divide both sides by 2 first. So that's going to give me x over 2 equals log base 7 of y minus 5. Now I'm going to put it in exponential form. Remember, our base is our base. So we're going to take this right here, 7, and we're going to take it to that power, the x over 2 power. That's going to give us y minus 5. So then all we have to do is add 5 to both sides, right? So our answer is going to be 7 to the x over 2 plus 5 is equal to y. That's our first one. Okay, let's do this next one. So in this one, again, I'm going to write this y equals log of 2x plus 4 first. Then I'm going to swap my x and y. X is equal to log of 2y plus 4. So obviously we're going to subtract the 4 from both sides here. So it's going to be x minus 4 equals log of 2y. Now hopefully you remember that there's a base 10 here. If there's no base, that's our base. So then we're going to take our base 10 to the power of x minus 4. That's going to be equal to 2y. So then we're going to just divide both sides by 2. So our answer is going to be x to the 10 to the x minus 4 over 2. That's what's equal to y. Our last one over here, again, swapping the x and y. So this is going to be x equals 4 to the 5, y minus 3 plus 2. I'm going to subtract 2 from both sides. So that's going to give me x minus 2 equals 4 times 5 to the y minus 3. Then I'm going to divide both sides by the 4. So that gives me x minus 2 over the 4 is equal to 5 to the y minus 2. So now we can put it in log form. So remember, our base is our base, so it's going to be log base 5 of what's on the left over there. So that's x minus 2 over 4, and that's going to be equal to y minus 2. So to simplify this, we're just going to add 2 to both sides. And that's going to give us our answer, log base 5 of x minus 2 over 4 plus 2. That's what's equal to y. Okay, so let's go here. So now we're going to find the value of a for these, okay? So this first one's pretty easy because we're going to take our base here to the power. So it's going to be, I don't know what this thing is doing. Sorry, y'all. 3 to the 4th, which is equal to 81. That's what a is equal to. 3 to the 4th is equal to a, right? So, actually, let me back that up one. So 3 to the 4th is equal to a. So a equals 81. This one, we're going to do it using the change of base formula. So I'm going to do the log of 64 divided by the log of 4. Remember, keep the base in the basement. Keep it in the bottom. Okay, that's a great way to remember that. When we do this equals 3. We do that in the calculator. This one we're going to say a to the 5th power is equal to 32. And the way I do this is, remember, the way we get rid of this is to take this to the 1/5 power, which means that's what we're going to do over here. So a is really equal to 32 to the 1/5 power, which is equal to 2. Okay, so then here we're doing, again, the change of base formula. So we're going to say the log of 343 over the log of 7. Keep the base in the basement. That's also going to be equal to 3. Again, same thing here. So this is going to be log of 16 divided by the log of 4. That's going to be equal to 2. Now this one's a little bit different. So we have a base of 10, right? So we could just do this like this, right? Or we can do it in the calculator, log of 125. You could do the log of 125 over the log of 10, but you can really just do the log of 125. And that's going to just give you the answer of 2.0969. Okay, this next one, log of 1,000. Again, you can just do that on your calculator, and it's going to tell you that a is equal to 3. This one is, so with this one, I'm going to put it in log form. So it's going to be log base 5 of 625. That's going to be equal to a. So remember, now we can use the change of base formula, right? So we can say the log of 625 is divided by the log of 5. And wow, I don't know what is going on with my stuff today, y'all. Having major issues. And this one is 4. Okay. Then again, we're going to do the same thing for the last one. So we're going to say the log of 64 Log base 64 of 4 is equal to a. So we're going to do the log of 4 divided by the log of 64. And this one's going to give us 1/3. And this one, I'm just going to take this thing to the 1/4 power. So a to the 4th, we're going to do that to the 1/4, which means we're going to do the 16 to the 1/4. So a is going to be equal to 2. All right, so number 11, we're dealing with, it says graph the function. So before I do that, let's talk about our asymptote. Now, this is the way I did this with my students every time. So this right here, if you recall, is our asymptote. And our equation is x minus h plus k, where h is our horizontal movement and k is our vertical movement. So our asymptote is going to be x is equal to -3. So we're going to go ahead and draw that asymptote because our graph is going to approach that line, but it's never actually going to touch it. And remember, that asymptote relates back to our domain, and it relates to our intervals as well. So our domain is x is going to be greater than -3, okay? And so if we look at this graph and we start, and remember our range is going to be all real numbers. Okay, so transformations, so this is going to be a -3, right? So that means it's going left 3. And then this right here means it's going down 4, right? Okay, so to find our intercepts, now this graph is going to have an x-intercept and a y-intercept. So I'm going to scroll this up a little bit and we're going to work both of these. So first we're going to say 0 equals the log of x plus 3 minus 4. So we're going to add that 4 to both sides. So this is going to be 4 equals log of x plus 3. Now remember, we have this base of 10 down here. So we can say 10 to the 4th is equal to x plus 3. That's going to be 10 with 4 zeros equals x plus 3. So this, our x-intercept, is going to be 9,997 equals x. So that's going to be our 0. X equals 9,997. It's also going to be our x-intercept. So we're going to say 9997, 0. Now we're going to find our y-intercept, and the way we're going to do that is we're going to put 0 in for x, okay? So now we're going to say y equals, and we're going to do the log of 0 plus 3 minus 4. So when we do that, we get y is equal to -3.523. And that would have been 2 rounded up because the number after the 2 is larger than 5 or larger. Okay, so now this is going to be our y-intercept. So this one's going to be 0, -3.523. So we can go ahead and plot that point about there, right? So we know this graph is going to approach that asymptote, and it's going to go up from there. So when I went and looked at 10, I saw it was like 2.8, so that's about there. And when I looked over here to the left, I know that it's going to approach over here. So I'm just going to draw my graph like this. Whoa, shouldn't be wavy like that, y'all, but you get the drift, okay? So it's going to approach the asymptote, is not going to touch it, okay? So is this graph increasing or decreasing as we look at it from left to right? Yes, it is increasing. So it's increasing from where? From there to infinity over here, right? So where is this point? -3. So that's going to be our interval of increase. It's going to increase from -3 to infinity, and it's not going to decrease. So this is going to be none. Okay. We already have our asymptote. So now we want to talk about, as we head towards infinity over here on our graph, as we go this direction, where's the graph headed? Isn't it headed up, y'all? It is. And then as we head this direction towards negative infinity, where's the graph headed? It's headed towards negative infinity. Okay, got one more. So on this one, again, let's talk about our asymptote again. So that's what this is right here. So that means our asymptote is going to be x. Oh, something happened. Pen is not wanting to work today. X equals 4, right? So we're going to draw our asymptote here. And remember, our asymptote and our domain are connected, right? So we're going to say x is going to be greater than 4. Our range is going to be all real numbers here. Let's talk about our transformations. That 4 means it's going 4 right. And then that plus 6 means it's going 6 up. Okay, so now this one's not going to have a y-intercept, is it? It's not going to intercept the y-axis because the asymptote's to the right of the y-axis. So the only one we have to solve for this time is the x. So we're going to say 0 equals negative log of x minus 4 plus 6. So we're going to subtract the 6 from both sides. So that's going to be minus 6 equals minus log of x minus 4, right? So if there's a minus there, we know that that's a minus 1. Do y'all know this? This is a minus 1 here. So we're going to divide it by minus 1 and that by minus 1. So that's going to give us down here a positive 6 equals log of x minus 4. And hopefully, again, you remember that if there is no base, the base is 10. So we're going to do 10 to the 6th is equal to x minus 4. 10 to the 6th is 1, 2, 3, 4, 5, 6. That's 1 million, y'all. And that's equal to x minus 4. So this is actually going to be 1,000,004. That's going to be our x, right? Whoops, that's not another. Shouldn't have a. Sorry about that, y'all. So that should be a 4, and that's equal to x. So that's going to be our x here is going to be 1,000,004. But this is also going to be 1,000,040, right? So way out there to the right, the graph is going to intercept the x-axis, okay? So that's 1,000,004, comma, 0. So let's go ahead and draw this graph now. Again, you can go to Desmos and look at it there. This is what I noticed when I was at 5. It was at 6. The graph again is going to approach over there and then it's going to come out. I think when I looked at 10, it was like a little bit above 5. So I'm going to come out this way. Sorry, again, I'm not drawing very straight lines, y'all. So that's about what my graph looks like. So is this graph increasing or decreasing, y'all, as I move along it from left to right? Right, it is decreasing. So then this is going to be none here. Let's talk about our interval again. So where is it decreasing from? From there, which is 4, on to where? Infinity over here, right? So this is going to be 4 to infinity. Now let's talk about our end behaviors. So as the graph goes towards infinity here, where's the graph headed? Is it headed up or down, y'all? It's headed down, so it's headed towards negative infinity, right? And now as I head towards the left here, where's it headed? It's headed up, so it's headed towards infinity.